Hello everyone, welcome back. Today we're going to learn the absolute value and piecewise functions. To be honest, I do not know what is a piecewise function.
Piecewise functions.
Okay, let's get into it. We don't say. We just have a few videos to watch. We just need to watch a few videos. And that's all. Okay, let's get into the first video.
This right over here is the graph of y is equal to absolute value of x, which you might be familiar with. If you take x is equal to -2, the absolute value of that is going to be 2. -1, absolute value is 1. 0, absolute value is 0. 1, absolute value is 1. So on and so forth. What I want to do in this video is think about how the equation will change if we were to shift this graph. So in particular, we're going to first think about what would be the equation of this graph if we shift 3 to the right, and then think about how that will change if not only do we shift 3 to the right, but we also shift 4 up. Shift 4 up. And so once again, pause this video like we always say and figure out what would the equation be if you shift 3 to the right and 4 up. All right, now let's do this together. So let's just first shift 3 to the right and think about how that might change the equation. So let's just visualize what we're even talking about. So if we're going to shift 3 to the right, it would look like this. So that's what we first want to figure out the equation for. And so how would we think about it? Well, one way to think about it is, well, something interesting is happening right over here at x equals 3. Before, that interesting thing was happening at x equals 0. Now it's happening at x equals 3. And the interesting thing that happens here is that you switch signs inside the absolute value. Instead of taking an absolute value of a negative, you're now taking the absolute value as you cross this point of a positive. And that's why we see a switch in direction here of this line. And so you see the same thing happening right over here. So at this point, right over here, we know that our function, we know that our equation needs to evaluate out to 0. And this is where it's going to switch sign. And so we say, okay, well, this looks like an absolute value. So it's going to have the form y is equal to the absolute value of something. And so you say, okay, if x is 3, how do I make that equal to 0? Well, I can subtract 3 from it. If I say y is equal to the absolute value of x minus 3, well, let's try it out. Let's see if it makes sense. So when x is equal to 3, 3 minus 3 is 0. Absolute value of that is 0. That works out. When x is equal to 4, 4 minus 3 is 1. Absolute value of 1 is indeed 1. And if x is equal to 2, well, 2 minus 3 is -1, but the absolute value of that is 1. So once again, I'm showing you this by really trying out numbers, trying to give you a little bit of an intuition, because that wasn't obvious to me when I first learned this. That if I'm shifting to the right, which it looks like I'm increasing an x value, that what I would really do is replace my x with an x minus the amount that I'm shifting to the right. But I encourage you to try the numbers and think about what's happening here. At this vertex right over here, whatever was in the absolute value sign was equaling 0. It's when whatever was in the absolute value sign is switching from negative signs to positive signs. So once again, if you shift 3 to the right, that has to happen at x equals 3. So whatever is inside the absolute value sign has to be equal to 0 at x equals 3. And this, pause this video and really think about this if it isn't making sense. And even as you get more and more familiar with this, I encourage you to try out the numbers. That will give you more, instead of just memorizing, hey, if I shift to the right, I replace x with x minus the amount that I shift. Always try out the numbers and try to get an intuition for that, why that works. But now let's start from here and shift 4 up. And shifting 4 up is in some ways a lot more intuitive. So let me do that. Let me shift 4 up. All right, so let me move. I'm going to go up 1, 2, 3, and 4. I think I got that right. So now I've shifted 4 up. And just as a reminder of what we've even done, the first part, we shifted 3 to the right. And now we are shifting 4 up. So now we are shifting 4 up. So before, y equaled 0 here, but now y needs to be equal to 4. So whatever this was evaluating to, we now have to add 4 to it. So when we just shifted 3 to the right, Our equation was y is equal to the absolute value of x minus 3. But now whatever we were getting before, we now have to add 4 to it. We're going up in the vertical direction. So we just have to add 4. Now this makes a little bit more sense. If you're shifting in the vertical direction, if you shift up in the vertical direction, well, you just add a constant by the amount you're shifting. If you shift down in the vertical direction, well, you would subtract. If we said shift down 4, you would subtract 4 right over here. The less intuitive thing is what we did with x. Is when you shift to the right, you actually replace your x with x minus the amount that you shifted. But once again, try out numbers until it really makes some intuitive sense for you.
All right, let me just repeat the process of the thinking. So what you have is a value inside of the absolute sign. And as you know, the absolute sign is for any kind of number inside of that. The absolute value of 0 would be always equal to 0. So now if you give me a expression, or let's say, if you give me an expression called x minus 4, then what kind of the x would it be to let it equal to 0? Well, it's very obvious that the x should be equal to 4. I don't know if you understand that or not, but for this one, the graph for it would be this, because the x for this one is 3. Alright, let's go.
Function g can be thought of as a stretched or compressed version of f of x is equal to the absolute value of x. What is the equation for g of x? So you can see f of x is equal to the absolute value of x here in blue. And then g of x, not only does it look stretched or compressed, but it also is flipped over the x-axis. So like always, pause this video and see if you can come up yourself with the equation for g of x. Alright, now let's work through this together. So there's a couple of ways we could do it. We could first try to flip f of x and then try to stretch or compress it, or we could stretch or compress it first and then try to flip it. Let's flip it first. So let's say that we have a function that looks like this. It's just exactly what f of x is, but flipped over the x-axis. It's just flipped over the x-axis. So all the values for any given x, whatever y you used to get, you're now getting the negative of that. So this graph right over here, this would be the graph. I'll call this y is equal to the negative absolute value of x. Whatever the absolute value of x would have gotten you before, you're now going to get the negative, or the opposite of. So this is getting us closer to our definition of g of x. The key here is, how do we appropriately stretch or squeeze this green function? So let's think about what's happening. On this green function, when x is equal to 1, the function itself is equal to negative 1. But if we want it to be the same as g, we want it to be equal to negative 4. So it's actually 4 times the value. For given x, at least for x equals 1, g is giving me something 4 times the value that my green function is giving. That's not just true for positive x's, it's also true for negative x's. You can see it right over here. When x is equal to negative 1, my green function gives me negative 1, but g gives me negative 4. So it's giving me 4 times the value. It's giving me 4 times the negative value, so it's going even more negative. So what you can see, to go from the green to g, you have to multiply this thing right over here by 4. So that is what essentially stretches it down in the vertical direction. So we could say that g of x is equal to, it's not negative absolute value of x, negative 4 times the absolute value of x. And you could have done it the other way. You could have said, hey, let's first stretch or compress f. You say, all right, before we even flip it over, if we were to unflip g, it would look like this. If we were to unflip g, it would look like this. If we were to unflip g. So this thing right over here, this thing looks like 4 times f of x. We could write this as y is equal to 4 times f of x. Or you could say y is equal to 4 times the absolute value of x. And then we have a negative sign. Whatever positive value you were getting before, you now get the opposite value. And that would flip it over and get you to g, which is exactly what we already got.
To be honest, this video was quite boring. Alright, let's get into the piecewise function. What is that?
By now we're used to seeing functions defined like h of y is equal to y squared, or f of x is equal to the square root of x. But what we're now going to explore is functions that are defined piece by piece over different intervals. And functions like this are, you'll sometimes view them as a piecewise, or these types of function definitions, they might be called a piecewise function definition. And so let's take a look at this graph right over here. This graph, you can see that the function is constant over this interval for x, and then it jumps up to in this interval for x, and then it jumps back down for this interval for x. So let's think about how we would write this using our function notation. So if we say that this right over here is the x-axis, and if this is the y is equal to f of x axis, then let's see, our function f of x is going to be equal to, let's see, there's 3 different intervals. Let me give myself some space for the 3 different intervals. Now this first interval is from not including -9. I have this open circle here, not a closed-in circle. So not including -9, but x being greater than -9 and all the way up to and including -5. So I could write that as -9 is less than x, less than or equal to -5. That's this interval. And what is the value of the function over this interval? Well, we see the value of the function is -9. It's a constant -9 over that interval. It's a little confusing because the value of the function is actually also the value of the lower bound on this interval right over here. And it's very important to look at that this says -9 is less than x, not less than or equal. If it was less than or equal, then the function would have been defined at x equals -9, but it's not. We have an open circle right over there. But now let's look at the next interval. The next interval is from x is greater, or -5 is less than x, which is less than or equal to -1. And over that interval, the function is equal to, the function is a constant 6. It jumps up here. Sometimes people call this a step function. It steps up. It looks like stairs to some degree. Now it's very important here that at x equals -5, for it to be defined only one place. Here it's defined by this part. It's only defined over here. And so that's why it's important that this isn't a -5 is less than or equal to, because then if you put -5 into the function, this thing would be filled in, and then the function would be defined to both places, and that's not cool for a function. It wouldn't be a function anymore. So it's very important that that when you input -5 in here, you know which of these intervals you are in. You can't be in two of these intervals. If you are in 2 of these intervals, the interval should give you the same value so that the function maps from one input to the same output. Now let's keep going. We have this last interval where we're going from -1. We're going from -1 to 9, from -1 to +9, and x, it starts off with -1 less than x, because you have an open circle right over here, and that's good because x equals -1 is defined up here, all the way to x is less than or equal to 9. And over that interval, what is the value of our function? Well, you see the value of our function is a constant -7, a constant -7. And we're done. We have just constructed a piece-by-piece definition of this function. And actually, when you see this type of function notation, it becomes a lot clearer why function notation is useful even. And hopefully, well, anyway, hopefully you enjoyed that. I always
Piecewise functions. Okay. It just means that for different range of inputs, we use a different expression to get the outputs. I guess that's the idea of that. And I must say, this is very common even in the programming, because for most of the time we have to make sure that we use different calculations to process different function inputs or arguments. Let's say we just wanna, okay, I do not think that we need to watch more videos for today. I guess this is enough. So inside of this video, we have learned about the idea of absolute value. Okay, you may not understand that, but let me give you a general idea. So for example, now if we get a value called -5, let's say this is a number called -5. What's the absolute value of it? Well, you could just import, or you could not import. You could say the absolute value of -5 equal to 5, and the absolute value of 5 also equal to 5. And you can even try more numbers. For example, the -1. What's the absolute value of -1? It's 1. Okay. And also, inside of this video, we have learned about the concept of piecewise functions. And the idea for the piecewise function is to map different range of inputs to different expressions to get different outputs. Alright, that's it. I hope you enjoyed this video, and I'll see you guys in the next one. Bye!